Very interesting. Okay. Hello. How may I contribute to your health today? Thank you for calling Kizashi Wellness. Bless you. Oh, sure. Is it indigestion that you're experiencing? Does it feel like food is not moving in your stomach for more than 3 hours? Would you say this is happening after eating certain things? Is it more chronic, every day, throughout the day kind of thing? What would you say? I see, I see. In that case, I think you're better off with an enzyme supplement as opposed to a probiotic. So taking an enzyme supplement symptomatically. Well then, allow me to tell you. Welcome to the Learn Before You Buy video series. I made a couple of dialogues on this, but every time I edited, the video was about 45 to an hour long. Considering the current state of my channel, I think it's better I keep my videos shorter than that, but it sucks because there's just so much information. I do have a plan for this, but for now, let's not waste any more of your time. Hey, Sophie. Alright, so enzymes are unique and specialized protein molecules that act as a catalyst and speed up reactions or chemical reactions in our cells. We produce so many enzymes. I mean, we've identified only around 1,300 of them in the human body. We need them for metabolism, liver function, cellular repair, conversion of one chemical into another, and other things including digestion. Each enzyme has a specific job and they work on a particular substrate. They have a unique activation site that is complementary to the shape of the target substrate, fitted together like a lock and key. Once they get into contact with the targeted substrate, they cause it to change, making a new chemical. Good question. A chemical is simply any substance that has a defined composition and distinct properties. You may think of this, right? Well, how about amygdalin, proanthocyanins, hydrogen hydroxide, sodium chloride, and oxygen? These are all chemicals. Even if the name may sound a little much, that doesn't equate to them being bad. Chemistry does good for the heart. So again, the enzyme makes a new chemical or product, but one of the most awesome parts is that the enzyme itself doesn't get used up or damaged after performing a task. Even after its action is done with that substrate, the enzyme itself stays the same and goes on to continue catalyzing another similar substrate until it's decommissioned. I always say that enzymes are incredible examples of productivity following the body's ubiquitous rule of recycle and reuse. Yeah. To fully understand enzymes, it's important to understand how they're made the same way all other proteins are made. All proteins are made from amino acids and are folded into specific shapes that enable them to carry out specific functions. The DNA in the cell's nucleus has special instructions to make all proteins. The DNA will be transcribed into mRNA, the messenger ribonucleic acid. The mRNA, after being molded, will then move to the cytoplasm of the cell. After that, with the help of ribosomes and transport ribonucleic acid, tRNA, the mRNA will be translated into a chain of amino acids. This tRNA transports each individual amino acid to the chain so that they can be assembled and folded into specific protein shapes. Pop quiz. When a protein is folded into a specific shape, what does that give it? Specific properties. It can be used to make an enzyme, a tissue building protein, an immune complex protein, or whatever the cell is instructed to make. For these enzymes to demonstrate their properties and function as a catalyst, they need coenzymes and cofactors. For example, prolyl hydroxylase requires ascorbate, or vitamin C, and iron. Glutamate cysteine ligase catalytic unit and glutathione synthase both require magnesium. Glutathione peroxidase requires selenium. Superoxide dismutase requires manganese, and catalase requires iron or manganese, depending on what it needs at that time. We won't get into endogenous enzymes like butyrylcholine esterase or aromatic L-amino acid decarboxylase. No. Let's stick with supplemental enzymes. There are two main types of enzyme supplements, digestive and systemic. Digestive enzymes are taken with meals to help break down food faster, save energy, and improve nutrient absorption. Systemic enzymes, however, support overall bodily functions like inflammation modulation, cardiovascular, and way more, but we won't cover those in this video to save time. Absolutely. Digestive enzymes facilitate, well, digestion, right? As the name implies. These enzymes break down macronutrients like protein, carbohydrates, and lipids into micronutrients like amino acids, simple sugars, and fatty acids through a process known as hydrolysis. They're breaking down complex molecules into simpler forms by using a water molecule to break those chemical bonds. These enzymes are produced from the mouth all the way down to the small intestine. So as you can imagine, there's a lot of metabolic energy taking place there. This process allows the nutrients from the food to be broken down and absorbed into the intestines, and in small cases in the mouth and stomach, so they can be effectively utilized by the body. Something to remember, micronutrients are building blocks to macronutrients, right? The body wants to be able to piece together and create whatever it needs for its own uses and purposes. For example, the body will use amino acids to build different proteins like enzymes or organs or collagens or whatever it wants, whatever kind of protein it wants to build. The body will use fatty acids as structural and functional components of all cellular membranes. The body will use simple sugars as the primary source of energy, or it will store it away in the liver in the form of glycogen. There is a problem, however. Due to a number of factors, some people may not be digesting properly and macronutrients can pass into the small intestine, leading to diseases like malnutrition, obesity, chronic constipation, and more. It could be something simple like chronic dehydration, lack of exercise, or improper diet, somewhat complex like stress, anxiety, and depression, or very complex like exocrine pancreatic insufficiency or a genetic disorder like enterokinase deficiency. It does, you're right. Fortunately, it's a rare one because, yikes, look at this study. Well, before we think about what to take, let's give some appreciation to what our body does for us as long as it's functioning properly. We have safeguards to prevent poor digestion of macronutrients from causing problems. This is especially important because in the case of, let's say, exocrine pancreatic insufficiency, which is unfortunately too many people who have this are misdiagnosed of having IBS and don't get the proper treatment until they have a good gastroenterologist that gets someone at least an esterase test. But anyway, for one, the lining of the small intestine is designed to selectively absorb nutrients while blocking larger undigested particles. This barrier prevents harmful substances from entering the bloodstream, obviously, right? As I mentioned before, we produce digestive enzymes in several parts of the GI tract. The small intestine secretes a few, known as collectively as the brush border enzymes. These are not efficient for macronutrients, but our bodies are smart. These babies are ready to make the final touches. We'll touch on that a little bit later on. Our intestinal muscles have rhythmic contractions known as peristalsis. I'm sure you've heard of it. Without it, we couldn't swallow food, nor can we poop. The contractions are well orchestrated, not too slow to prevent stagnation of food, but not too fast to inhibit the small intestine from doing what it has to do, or to take away the time needed for the villi to absorb nutrients passing along the way. Keep in mind, we need fiber for peristalsis to work properly as well. Like, okay, you ever had a stretch of weeks where you had like low fiber foods and had those little baby pellet poops? Yeah, that's part of the reason why. Another way is GALT, and whoa, hold on a second. This is a family-friendly channel. GALT, gut-associated lymphoid tissues. The lumen, or the hollow through the entire GI tract, is considered an external layer. It's an open tube from one end to the other. Because of this, it's protected by the mucosal layer, of course, and is lined with different types of immune cells as your first defense against pathogens. GALT, in a super nutshell, is one of those safety reinforcements set to monitor and respond to potential threats, including undigested food particles. The human gut-associated lymphoid tissues is undergoing a lot of research. You see, if these macronutrients, the proteins, fats, carbs, get absorbed directly into the bloodstream somehow, some way, that's a recipe for disaster in the long run. One of the first problems is nutrient malabsorption, as the body will not be able to absorb these big compounds and utilize the nutrients for energy, growth, repair, and so forth. If undigested protein make it past the intestinal safeguards I mentioned, it can contribute to leaky gut syndrome. Medically, we call this intestinal permeability. where the lining of the gut becomes inflamed, damaged, and permeable, allowing undigested food particles and other substances like pathogens to enter the bloodstream when they shouldn't. This constant bombardment will eventually make the immune system see the food and its nutrients as foreign invaders, and boom, you have a food allergy. This triggered immune response, happening over and over, leads to further degradation of the epithelial barrier and leads to more intestinal permeability. As if we need another reason, intestinal permeability and the subsequent gut microbiota composition alterations can lead to liver damage. The exact pathogenesis, while well documented, definitely needs more research, but this is something that you really want to avoid. Folks who otherwise have trouble breaking down their foods, whether it's chronic or acute, don't fear, digestive supplements are here. Okay, that was kind of lame. The most commonly found supplemental digestive enzymes are amylase, protease, and lipase. Before we get into that, let me clarify that digestion does not start in the stomach. I know you didn't say that, but I'm just saying. Digestion starts in the mouth. Some may say that digestion starts with the central nervous system, specifically the brain, but that's not true either. The central nervous system starts conditioning the GI tract. You think of food, you see food, you get hungry for it, you salivate, your stomach rumbles, your gastric fluid starts to flow in preparation. Nothing is being digested at this time, it's just conditioning and preparing. So again, digestion in of itself starts in the mouth. You masticate or chew to mechanically break down a food. And salivary secretions produce saliva to soften food and enzymes to start the chemical breakdown. Lipase is crucial for breaking down fats and oils, all lipids. Lipase, so lipase, how you pronounce it, but still. Lipase break down fatty foods, make lipid-soluble nutrients like A, D, E, K, omega fatty acids, and such and so forth much easier to absorb. Lipase is produced in 3 parts of your GI tract: lingual lipase, gastric lipase, and pancreatic lipase. One thing to say about the pancreatic lipase, however, its optimal pH is 7.5 to 8.5 in vitro. However, in vivo is 6.5 due to the presence of bile salts. The small intestine doesn't produce lipase, but it is a site where pancreatic lipase works. Lipids take the longest and the most energy to digest. This is why folks may feel sluggish after a while after eating a super fatty, greasy meal. Good on you for making that connection. So bile isn't an enzyme. It's a mix of cholesterol, bile salts, biliverdin, and bilirubin, the latter two essentially waste products that give your poop its brown color. Biliverdin being green, bilirubin being yellow. They both come from the breakdown of old red blood cells. Remember recycle, reuse? This combination making up bile converts lipids passing from your stomach into duodenum into fat droplets. These are then further broken down into fatty acids and glycerol, which are the building blocks of lipids. Little fun fact, the gall and gallbladder is another word for bile. Pop quiz. So you know that lipase breaks down lipids, but what does amylase break down? What was that? Carbohydrates? Close, but that. Say it again. Lipids? Starches. Okay, that's right. Starches. Good job. You see, not all carbohydrates are starches. There are several types of carbohydrates, but let's just talk about a few. You have the monosaccharides. These are just simple sugars like glucose, fructose, and galactose. Oleosaccharides, which are carbohydrates made of a small number, like 3 to 10 of monosaccharides put together, such as inulin and galactin. You got fibers. These are complex carbohydrates that the body cannot digest. These help with intestinal clearance and maintaining gut health or gut flora. You have starches. These are complex carbohydrates found in foods like potatoes, rices, and grains. They are made up of very long chains of glucose molecules. But what's in a word? Lipase, understandable, but amylase? Well, like most things in medicine, amylase comes from a Greek word. In this case, amylon, which means starch. This is because amylase is an enzyme that catalyzes the hydrolysis of starches into simple carbohydrates. The term amyl is often used to refer to starch or related compounds, which is why complex carbohydrates are sometimes associated with the prefix amyl, like amylose or amylopectin. Yeah, sorry, I forgot to say. So the suffix ase indicates that whatever the compound is an enzyme. Amylase is produced in fewer parts of the GI tract compared to lipase. There are two main types: salivary amylase, or phthalate, and pancreatic amylase. Oh yeah, the phthalate is also why rice, pasta, and bread taste sweeter the longer you chew them. Side note, so I mentioned two enzymes that are produced from von Eberner's, the parotids, submandibular, and these sublingual glands, both being lingual lipase and salivary amylase, or phthalate. These two alone are huge reasons why it's super important to properly chew your food and to be adequately hydrated every single day. Now let's get into the bulk of digestive enzymes, proteases. You may also hear them called proteinases or proteolytic enzymes. There are quite a lot of protease enzymes in the body, and definitely more than a handful that work in the GI tract. These digestive enzymes break down proteins by acting on the internal peptide bonds and the terminal peptide bonds of the protein. If you aren't aware, proteins are long chains of peptides. That is very true. I did. Let's look at that again. Remember this diagram? So peptides are short chains of amino acid sequences linked together by rigid and planar peptide bonds. Because these strong bonds help stabilize the protein structure, we gotta make sure they get snapped. Peptidases are subsets of proteases that specifically target peptide bonds, breaking them down into individual amino acids or smaller peptides. You can comfortably call a peptidase a protease and vice versa, without anyone trying to check you. If they do, tell them to explain trypsin and watch them stumble on their words. Don't worry, I got your back. There are no proteases in the mouth, but you will find them in the stomach, the pancreas, and the small intestine. The protease and peptidases are pepsin, trypsin, chymotrypsin, elastase, carboxypeptidase, aminopeptidase, and dipeptidopeptidase. Here's a KWPSA for you. Make sure your gastrointestinal organs are in good order by living good, de-stressing, staying adequately hydrated, eating good, exercising, and make sure that you get any chronic ailments addressed by your gastroenterologist, your physician, or your practitioner. All right, cool. Let's continue. Like I said before, our bodies are amazing. It has mechanisms of actions that just constantly amaze me. Let's look at a couple real quick because I finna arm you with some knowledge. Trypsin. Without the production of trypsin, our pancreas can't activate chymotrypsin, elastase, or carboxypeptidase. Remember how I said all organs are made out of proteins? What do you think will happen if we stored active protein hydrolyzing enzymes for hours at a time? They won't just hang around, they will digest our stomach and pancreas, then leak out and digest surrounding tissue, and we won't make it past infancy. Due to such reasons, our stomach and pancreas store these proteolytic enzymes as zymogens. These zymogens are inactive precursors ready to be activated whenever they're needed. So you see how enzymes work in specific pH ranges and temperatures as well, and in a sequence, sort of like workers on a farm or on an automotive factory or a supplies warehouse. One breaks down one segment of a macronutrient, another breaks down another segment, and so forth. However, there's also teamwork. Everyone needs to do their own independent work, but they need to be able to work together to get the bigger job done. Our bodies working in this kind of synergy is just so amazing, isn't it? Funny, no. Brushed border enzymes. I always like that name, you know, but anyway. These enzymes are anchored to the apical cell surface, a specialized region of epithelial cells along the microvilli in the small intestine. You also will find these kind of cells in the kidneys and I think one other organ. This cell surface faces the lumen, allowing content to brush along and come into contact with these special enzymes. They play a very crucial role in the final stages of digestion, though bacteria along the GI tract technically take that role. But in regards to enzymatic digestion, yeah, these will do it. You have maltase, sucrase, lactase, dextrinase, glucoamylase, aminopeptidase, dipeptidase, and I think that's it. Whoa, hold on there, Tigris. Allow me to explain. Excluding the two peptidases, I see that you noticed the other enzymes, especially glucoamylase. Maltose, sucrose, and lactose are disaccharides, where they break down into two monosaccharides or two simple sugars. So therefore, you can call these specific carbohydrate hydrolyzing enzymes saccharidases. And remember, amylase only breaks down starches. So most of the time, an amylase only partially hydrolyzes the starch or partially breaks down the starch. The product it leaves behind are more simple carbohydrates, which are said to be further broken down by the brush border enzymes in order to release the glucose for the body to use. Unlike amylases, which can break down starches all over, glucoamylase can only break down the bonds at the end of carbohydrate chains to release the glucose that is already present. Thus, its name glucoamylase. I know this is really confusing, and I feel like this enzyme should be renamed at this point to glucopolysaccharidase. Here's a bit of history. The thing about it is, like, glucoamylase was discovered a long time ago. I don't have any evidence of when, but it's one of the oldest biocatalysts in the food industry. So I'd say it was isolated sometime after amylases were discovered, which is back in 1811 by Kirchhoff, and more in depth in 1833 by Payne. Mind you, Carl Schmitt proposed the term carbohydrates in 1844, and Claude Bernard discovered glycogen, which is a carbohydrate storage molecule, in 1856. So this leads me to believe that amyl was put on carbohydrates before carbohydrates were even discovered. Anyway, if not for glucoamylase, partially digested carbohydrates can clump together, causing constipation from them binding up, or diarrhea from irritation, bloating, abdominal heaviness, and pressure. Bacteria will use these clumps as a food bank, and yeah, obviously that's not good. Dextrin is an oligosaccharide and one of the products after amylase breaks down the starch. Dextrinase breaks down alpha dextrin into multiple glucose molecules. It's a pretty good payout. These are all products of starches that were partially hydrolyzed. They are carbohydrates that can be broken down further into multiple glucose molecules. Remember, maltose, sucrose, lactose, dextrose, oligosaccharides, all saccharides, amylose, starches, simple sugars. They're all carbohydrates, but not all carbohydrates are starches. I want to make that super clear when you're learning about enzymes. Amylases break down starches into smaller carbohydrates like maltose and simple sugars like glucose. Glucose, fructose, and galactose are as broken down and simple as possible. These are monosaccharides. Maltose is a disaccharide, so it has two more sugar molecules it can be broken down into. Amylase can do that, but maltase darn sure can. In fact, maltase can't break down lactose. Similarly, lactase can't break down maltose. They're very specific in what substrates they're breaking down. That's why they're enzymes, very specialized proteins. In fact, amylase also can't break down fibers. Humans don't eat super amounts of highly dense packed cellulose, like no one's out here eating grass, right? So we had never developed the need for enzymes to break down these specific types of carbohydrates. Fiber passes through the GI tract largely intact and undigested, contributing to gut health, cardiovascular health, hormone health, such and so forth. They do get fermented and partially digested by bacteria in our microbiome, but that's pretty much it. It's not enzymatically. That being said, if you're having a tough time breaking down the likes of kale or cabbage, then cellulase enzymes do exist. Lactose intolerance. Oh boy. So lactose intolerance is common worldwide, especially at this point. It is super common. I used to think it was due to drinking milk beyond infancy. The more you drink milk, the more you waste your levels of lactase. But that's not true at all. Okay, that's been proven wrong. It's actually influenced by genetics and natural decline. In a complete nutshell, is called lactose persistence. Lactose persistence is an inheritable genetic trait in which someone can consume and digest lactose throughout their adulthood. On the flip side, lactose non-persistence is where individuals stop producing the enzyme lactase past some point in their adolescence. In 2010, an estimated 65% of human adults, or most adult mammals, downregulate the production of intestinal lactase after weaning. Regular dairy consumption and consuming Lactobacillus genus bacteria can help maintain some level of lactase activity, specifically through gut microbiota adaptation, though I think starting young would definitely be the best option. Another way to have your cup of milk and drink it too is switching to fermented dairy. That's pretty much what I did in my mid-20s after having a certain amount of dairy beyond what was already my threshold was becoming uncomfortable. I'll never forget that moment. Anyway, fermented dairy products digest way easier thanks to the bacteria inside producing their own lactase and breaking down the lactose in the milk before you even drink it. Believe it or not, this is a huge game changer. I'm not one to consume dairy unless it's fermented, but if you want to drink milk more often or whatever, or eat cheese and you're lactose intolerant, then do it this way. But you can contact a practitioner like myself or a medical professional to find ways to make that work better for you. Nope, sorry. Let's talk about the general advantages and disadvantages of enzymes. They are incredibly efficient and specific, speeding up chemical reactions and making bodily processes work better. Trust me when I say this, without enzymes, simple functions like taking a breath would take hours. I don't really feel like getting mine because I don't feel like getting up, but take a look at these washing sheets from Ecos. There are enzymes in these washing sheets. Not only do they function well to bind to and free up stains and grime from clothing quicker than just sitting in soap and water, but they are biodegradable and cause less environmental pollution than most detergents, if any at all. When their function is complete, and this goes for all enzymes, when their function is complete and they're no longer needed, they can be broken down by other enzymes or microorganisms in the environment. They don't persist in the environment like synthetic or even some other natural chemicals do. Use, recycle, reuse, recycle. Because they're ubiquitous, they will always be of some benefit. Just like everything else on this planet, side effects and problems can happen. Drink too much water, water intoxication. Staying in an unventilated room, stale air all day long, you're on your way to skin irritations, headaches, and fatigue. Unprotected sun exposure for too long, risking sun damage or skin damage rather, premature aging, and increased risk of skin cancer. You want to eat something that is super healthy for you? You may have some kind of allergic reaction to it, and so on and so on. It just happens. It's just how things are. Not everyone can have everything. Enzymes in general can be denatured by changes in temperature, pH, and the presence of certain exogenous and endogenous chemicals such as phytic acid and alcohol. Digestive enzymes aren't really that expensive unless they're the systemic kind or just like really powerful options. Certain types, like some proteases, can cause nausea from irritating the stomach lining, or diarrhea due to the rapid digestion process increasing intestinal motility beyond what you may be used to, though temporary, very temporary. That being said, if you have peptic ulcers, I would strongly suggest avoiding protease enzymes to save yourself from the pain. You heard it here first. Just trust me. You can take an enzyme, just take a more mild option. A systemic enzyme, hard to say. You gotta gauge how your stomach is first, or do some anti-inflammatory support before you take a systemic enzyme if you have peptic ulcers. But otherwise, in general, I would say don't take any unless you absolutely need to. You don't need to take any systemic enzymes in this case, but the digestive, if you absolutely need to, then we'll do something mild. Otherwise, just don't take it at all. You know, I hear this a lot. Who told you that? Oh, well. Okay. I'm honored to deliver the news that enzymes are not stored in a finite amount. They are continuously synthesized, and degraded when necessary. How is this known? Because the body continuously produces new enzymes as needed every single day. Here's the thing. Remember, digestive enzymes are just literally enzymes. Humans, we eat carbohydrates, proteins, fats every single day. Our body wants to speed up this reaction known as digestion to fuel itself, so therefore we can live, right? So we have no reason to stop producing these digestive enzymes. As long as you don't have exocrine pancreatic insufficiency or pancreatic cancer or genetic disorder affecting enzyme production, you're good. Oh, if you're taking PPIs, they inhibit the stomach parietal cells from producing gastric secretions. You do remember what pepsinogen is, right? Right, zymogen. A reduction in stomach acid reduces the activation of pepsinogen into pepsin. Something to keep in mind in case you're having major indigestion, eating protein-rich foods while taking PPIs. Also, B12, but we'll say that that's a topic for another video. Even more so, taking enzyme supplements does not lead to dependency. Once you stop, your body will get right back to work. I did, but that fits in the genetic disorder category. Okay. Well, remember, enzymes are proteins, so it's really that simple. So to support enzymatic function, it's essential to maintain a balanced diet that provides the necessary nutrients for enzyme production. Consuming adequate protein is super crucial, obviously, because enzymes are made up of amino acids. We synthesize several amino acids, but the ones we can't synthesize, we must get from our food. Now, as far as vitamins and minerals, we spoke earlier about cofactors and coenzymes. Examples: zinc, magnesium, copper, B vitamins, vitamin C, and the rest of them. Like, there's a bunch of different coenzymes and cofactors. Without them, the enzyme can't perform their superpowers. It's like the Power Rangers needing their Morphers, or Sailor Guardians needing the Gem Tiaras, or Knights needing the Idia. Staying hydrated is important because enzymes function optimally in a well-hydrated environment. Think about it. Your oral enzymes get secreted with saliva, which is full of your stomach secretions come out as water. You get the point. Your gastrointestinal organs need water to secrete these enzymes in their fluid so they can move and do what they gotta do. Bitters and sour tasting foods, herbs, and beverages stimulate your GI tract and get you ready to break down what's coming in. The simple taste of something bitter makes you pucker up in your mouth water due to your receptors on your tongue, right? It stimulates your vagus nerve, which primes your liver, it activates more saliva to coat your throat, it gets your gastric and digestive juices ready to flow, and your gallbladder ready to pump out bile. So, final thoughts. I know this is already super long, so here are my final thoughts before I let you go. Digestion takes a lot of time. Food takes over 4 hours. Beverages, 15 minutes plus, all depending on what macronutrients are present and how much. Digestive supplements get an early start breaking down food in your stomach and intestines, so they help conserve energy and reduce digestion time. This also helps increase stomach emptying, so for people who have issues with gastroparesis, this can be helpful for you as well. Next thing, the composition of starches allows them to be broken down slowly to reduce hypoglycemia episodes. If you're taking supplements with amylase every single meal and have hyperglycemia or diabetes, you may want to tone that down by like a lot, okay? This will be sure to cause a blood sugar spike. For healthy individuals, that's not going to be a big deal. It shouldn't even cause a blood sugar spike, but just something to keep in mind if you have hypoglycemia or diabetes. If you do have these conditions, you can get around it in many ways. You can take a more mild enzyme supplement. You can take one without amylase. You know, there's things you can do. For someone who's purposefully trying to get an insulin spike for reasons like, high intensity training or something like that, you can use this to your advantage or to your benefit, but I'm not going to sit here and suggest anyone do that. I'm just making a statement. That's it. I can't stress this enough. Proper digestion of macronutrients aids proper absorption of micronutrients. It encourages a healthy intestinal environment, and it allows for proper elimination. For people who are suffering with enzyme insufficiency for whatever reason, and you have constipation, you can clear that up with taking an enzyme supplement for support, sometimes symptomatically. If you ever pick up an enzyme supplement and it shows the weight of each enzyme, the weight, milligrams, on the back of the supplement facts, remember, always read the supplement facts. I always say that. Put that crap back down on the shelf and look somewhere else. Remember, enzymes are specialized proteins. They are catalysts, so they function depending on pH and temperature. You need to find an enzyme supplement that shows its activity units, as this is how you measure their reactions. I will have a follow-up video explaining this as well. There's no set dose of digestive enzymes for every single person. There's no RDA of enzymes. It doesn't exist. It doesn't even make sense. It really is dependent on your circumstances and your conditions. So therefore, a typical serving size that's on the back of that product should suffice. That should be fine for you. But this is exactly why if someone asks me what is the best this, what's the best that, my answer is let's find what's the best for you. Everyone is different. Looking at enzymes on a supplement may be daunting. Sometimes the activity units may sound like a lot, but the fact of the matter is what is in that supplement is far from the amount that your pancreas would normally make. A healthy pancreas would normally make up to 720,000 units of enzymes for a small meal. The follow-up video will include my favorite supplement companies and why. So keep an eye out for that. Until then, thank you, Sophie. Thank you, Reika. Thank you, Shinji. And to you all, thank you for viewing this video. Thank you for coming to Exhaustion Wellness. I would try to be more consistent. I know I keep saying that, but social media. So anyway, thank you for tuning in. Like, comment, and subscribe if you want to see more. And I'll catch you on the next one.